Hey, Algebra 2. This is the first of two videos on what we're covering this week while I'm gone. So this is, hopefully you're watching this on Tuesday. I'm going to show you something called logarithmic form. The idea of logarithmic form fits very well with everything we've learned, especially when it comes to solving equations. We have learned all kinds of different ways to solve equations by subtracting 2 from both sides, dividing by 7. We've moved into the realm of square rooting. We're cube rooting both sides. This fits really well with that. That said, the structure of this is very strange, and we're only barely going to scratch the surface this week. And then starting the week before spring break, we'll really get deeper into these. But I want to familiarize ourselves with something called exponential and logarithmic forms before we ever get there, just to start getting comfortable and familiar. So this is exponential form. It's a pretty straightforward exponent. 4 squared is 16. Some people might incorrectly say that 4 squared is 8, but remember that squaring means timesing it by itself. So this is 4 times 4, which is 16. Okay. So this is made up of 3 parts: a base, a power, or what I'm going to call an exponent. There's an O. And this, I'm going to call this the argument. I'm getting this from your Carnegie book, which is how mathematicians would call it. I feel like in our class, we'd probably call this the answer, but it will fit much better with logarithmic form if we call this the argument. Either way, it's the argument slash answer. To convert this to logarithmic form, you will, how do I want to, I kind of got little arrows going on, but whatever. To convert this to logarithmic form, you can think about it, hey, it's going from this form to this form. I feel like if I leave those arrows there, it might be a little bit confusing. So these two are connected. I'm going to have 3 numbers, 3 parts, just like this has 3 parts, okay? My Algebra 2 class last year came up with a really cool way to convert between exponential and logarithmic form. The base, I like the name of that. It really is the base. It's our foundation. That stays the same. So if our exponential form has a base of 4, our logarithmic form also has a base of 4. The exponent and the argument swap. The exponent and the answer swap. So where the base stays the same, the 2 and the 16 switch positions. The argument is inside the log. The exponent is what it is equal to. So I'm going to rewrite this without the boxes. Here's exponential form. Log form looks like this. Log base 4, the base stays the same. And then I didn't do this last year, and so I'm trying to get used to this. I feel like it's better to always have the argument in parentheses. It may not always be necessary, but I think it will help whenever we get any kind of equation going on, any kind of x's. So this, you would read it like this. Log base 4 of 16 equals 2. And a logarithm asks the question 4 to what power equals 16. So if I didn't have this part of it there, this would be asking the question this would be asking the question 4 to what power is 16? Well, 4 squared is 16. And I'll prove it to you, and this is getting a little bit ahead, but I'll prove it to you here. You can do logs on the calculator in the math menu. It's way down here. Log base. I can say log base 4 of 16, and the calculator will say 2. The calculator is saying, yeah, 4 to what power is 16? 4 squared is 16. Okay. That's going to come in handy a lot, again, the next topic, and I will try and fill in some of those gaps when I'm back. Honestly, what you see right here on the screen is everything you need for the worksheet that you're doing today. This is it. You are converting between log form and exponential form, one way and the other. So one side of the sheet is exponential to log form, the other side's from log to exponential form. The base stays the same. The 2 other numbers, the exponent and the argument, swap spots. I like to talk more about what this means so that we can apply it and remember it better. So let me put a few examples down. I'm stealing these from the poster that's going to be up. It's up on the big board on the east side of the room. So here's exponential form. I could say something like 3 to the 4th power equals 81. You can use your calculator to confirm that. If I want to convert that to log form, I say log. The base stays the same. So log base 3. I switch the other two numbers, the argument and the exponent. I say log base 3 of 81, and that is equal to 4. 3 to what power equals 81? There, if I asked you to convert from exponential form to logarithmic form, that would be the answer. Okay, well, let's go backwards. So let's say I have log base, let's go base 10 of, and then I'll say the argument is 1,000 equals what? If you type that in the calculator, it will tell you it equals 3. There is logarithmic form. If I'm asked to convert this to exponential form, the base will stay the same, 10, and then the other two numbers will swap. The argument and exponent take different positions. So that's the exponent, and it equals the argument or the answer, 1,000. So every time I keep that base the same, and then I swap the argument and the exponent. Log base 10 of 1,000 equals 3 is the same as 10, same base, to the 3rd power equals 1,000. There's your basics. I want to show you one more thing that's going to come up on this worksheet, and then maybe one last example. Okay, so something that's going to come up on this worksheet, and that's just going to come up in math period, is log base 10, like the example that I just did. So log base 10 of 1,000 equals 3. And that is asking the question, 10 to what power equals 1,000? 10 to the 3rd power equals 1,000. I can prove it again by just saying, okay, 10 to the 3rd power equals 1,000. I can also show the other version. Log base 10 of 1,000 equals 3. Okay, the calculator is saying the same thing in both directions. Now, there's something that's really strange when, for instance, I have the square root of something. So let's say I ask for the square root of 25. That is equal to 5. By default, I wouldn't call this the base. This is, I think, the radicand is what it's called. But by default, this is the second root. That's by default a 2. Log is a really strange default. So if you have log with no base showing, so if I just say log of 1,000, oopsie, sorry. If I just say log of 1,000, by default, that base is 10. The default base for log is 10. It's really weird, but log is the inverse of 10 to the. So 10 to some power, the opposite of that is log, sort of like something squared and something square rooted are opposites. So I'll show that on the calculator here, and then I think we can be done. So if I type in the calculator log base 10 of 1,000, it tells me it is equal to 3. There is a dedicated log button on the left side. If I just do that with no base, it will also say that it's equal to 3. Because by default, the base is 10. And I'll just show you, does this always work? No. If I did log base 5 of 1,000, the answer is not going to be 3. Okay? So you'll notice they are the same if it's base 10 or just regular log. By default, log has base 10, but it's not the same as other ones. Log base 5 is going to be a different answer. I think that's enough. If you take a look at the notes, you take a look at the solutions and this video, you'll be able to complete Tuesday's worksheet with a cinch. There's a few stretch problems on both the front and back page. The last two problems are like a little bit of a stretch. Try them, look at how I solve them in my solutions, and see if you can make sense of them. Thanks.